So what we have here is we're going from A to B. A all the way to B. And in the first second of its motion, it travels 5 meters. A good exam technique, even if it's trivial, is to use your UVAS, lay out what you're doing. Starts at 0. Acceleration we don't know. We know that it travels 5. And we know that t equals 1. And I'm pretty sure we can just use ut plus a half at squared straight away. So 5 is equal to ut. Sorry, we'll call that s. S equals ut plus a half at squared. Then enter in s is equal to 5, which looks exactly the same. And then 0 times 1 plus a half a times 1 squared implies that a half a equals 5 and a equals 10. So pretty much I think nearly everybody got that. A is 10 meters per second squared, right? Now, where things get a bit difficult is deciding what to do, because you're told that in the last 4 seconds of its motion, so imagine we call this point C, and it's 4 seconds here. What I taught you guys, when you're using intervals, what I taught you guys is always try and use the starting off points. Under no you don't use CB. Why should you not use CB? Can anybody tell me why don't you use CB? What's the problem when you have to use CB? You're already moving, aren't you? So you're gonna have a U value you don't know, and then you know the acceleration is 10, and you don't know s, but you know t is 4 seconds. And then your s value is 16/25 of AB. It's a very difficult system to put yourself under. There's a much easier system available to you. And here's what my advice would be every time. Instead of using CB, sorry, C would be all the way over here. Instead of using CB as 16/25, why don't you use AC? Is 9/25. So AC is 9/25. And because you're using A again, guess what you can do? The U value can be, the U value is 0 then, and you're down a variable straight away. So that's the key there, is you're getting rid of the extra variable that you would have otherwise. And many people went down that route where you use CB instead. It's very difficult to get out there. I think Connor actually successfully got himself out there, but my God, it was complicated. It's not worth it. Alright? So it's best to make the correct move. It's best to make the correct move early. So we're going to go U is 0, A is 10, S we don't know, but we know it's 9/25 of the total distance. So let's call it 9/25 x for argument's sake. And T is, now here's the interesting part. We don't know the t value, do we? Or what do you reckon? Anybody got an idea for that? Well, I'm going to call the t value. Now I have to resolve the t value because I don't actually know the t value here. So get this. Here's what we're going to do. If the total time is t, is everyone happy that the total time is t? And the last 4 seconds get you from C to B. The last 4 seconds get you from C to B. What time do you think it is from A to C? Anybody? A to C? T minus 4. Is that okay? You're probably thinking, where am I going with this now? Well, let's find the full distance of AB, or x as I'm currently calling it. What is the full distance of x? I'll use UVAST over here as well. U, 0. The fact that both u's are 0 makes this incredibly easy, okay? V we don't care about. A is 10. S is x, which is the full distance. And T is capital T. and t here is t minus 4. How many variables do I have in total? I only have two of them, don't I? I just have x and t. If you use another system, I think you'd end up with slightly more. Okay? So here's what we're going to do. We're going to start off easy. We're going to get the tire distance x. So we're going to use ut plus a half at squared. And here's what we're going to do. We're going to use x equals ut, which is 0 times t, plus a half, 10 times t squared. And we get x equals 5t squared, right? We're going to go for AC now, which is 9/25 of x. And when we do that, we're going to get so once again ut, which is going to be 0 times t minus 4, plus a half a, so a half 10 times t minus 4 squared. Alright, so 9/25 x. Just going to take a shortcut with that, so it's going to be actually wait a second, 5, so it's going to be 5t squared. 4 times 4 minus 4 is 8, so it's going to be minus 40t. And then it's going to be 16 multiplied by 5, which is 80. Now, suppose what I might do here is this. I'll just say that 9x equals, multiply this by 25. 225t squared minus 1000t plus 2000. Is that alright? Plus 2000. 8 times x. See this one over here? I'll just call that 9x instead, which is 45t squared. So now I'm going to have 45t squared equals 125t squared minus 1000t plus 2000. Bringing it all onto one side. I'm going to have 80t squared minus 1000t plus 2000. And look, I'll save time here. You're all capable of solving that any way you want. I get two answers. I get t equals 5 over 2. Why is that not allowed? Why is t equals 5 over 2 not allowed? It says it takes 4 seconds to do the last sector. 4 seconds is bigger than that number, which means it disqualifies it. Has to be 10 seconds. Okay? So, first thing I don't want you to get mixed up with is just because they're going in opposite directions doesn't mean that you have to account for negative distance. Okay? So, best way of describing this is if two people are 40 meters apart, okay? If one of them moves across at 15 meters, the other one moves to the left at 25 meters. You don't use minus 25 meters just because it's going to the left. 15 plus 25 has to equal 40. So you're dealing with positive values for both trains. I think there was one lad who used negative values for some reason, was there? So just to get that out of your head, that when you're combining the two distances together, you can just deal with positive values, okay? So, somebody also used the relative method really well, so I'll show you how to do that in a minute. Okay, so both trains are side by side. Now, so 195 meters and 90 meters. Now what I told you to picture is this. Picture one of them. Picture one of them is stationary, completely stationary. Okay? So what we're going to do is we're going to pretend that this one can't move. Okay? It's not moving. How far does it have to go to completely clear the other train? Well, look, that's 90 metres right there, isn't it? To go from there to there. Okay? And then, if I want to bring this end, if I want to bring the red end all the way up to the blue part here. So I'm going to bring the red part all the way to the blue part. That's another 195 metres. So what's the total distance both trains have to travel? So SP plus SQ is 285 metres. That's the premise of the question. They have to travel 285 metres. Each train travels a different distance, but that's the deal. Okay? So, we're going to write down two lists for UVAST. A P list, so U, V, A, S, T. Let's call that SP. Acceleration of 1. U of 15. And then we're going to go for Q. U is 25. V is I don't know. A is 1.5. S is SQ. And T is T. Same time frame, isn't it? Okay. Let's just use UT plus a half AT squared. Okay. And we'll lob them in here. So we're going to get, for SP, we're going to get 15T plus a half 1 times T squared. Okay. For SQ, we're going to get 25T plus a half 1.5 times T squared. I'm going to add SP to SQ and I'm going to get 40T. What's that? That's 0.5 plus 0.75, which is going to be 1.25 T squared. And that equals 285. Bring everything to the left and do a minus B formula. And your answer will be 6 when you do the minus B formula. Okay? Another student decided to do the relative approach. Okay? And the relative approach would be like this. Once again, it's your same two diagrams, except for argument's sake, we're going to keep Q stationary. So Q is the purple one; it can't move. Is that all right? Q is in purple; it can't move. Okay, and this is going to be it's sort of faster. Okay, so what you're saying here is that Q is essentially stuck to the spot. So what's actually happening? Well, P is essentially going 40. Why is it going 40? Because in this case, if you're going 15 and the other one's going 25 and you're going towards each other, it's the same collision as 40 against 0. So that's 40 right there. Your acceleration, if your acceleration at 1 and the other one's accelerating at 1.5 towards you, that's an acceleration of 2.5. The distance remains the same. You still have to do 90, and then you have to do another 195 to pass it out. So that's still going to be 285. And your t value is still t. If you do s equals ut plus a half at squared directly on that, you'll end up right here, straight away. Half of 2.5 is 1.25 squared, and ut is 40t. So you essentially jump straight into the same equation, and you get the same answer. Yes? Now, next part is a weird question. So what it says is, your time gets reduced by 12.5%. Is that okay? Time is reduced by 12.5%. And there's a weird little answer at the end. Calculate the increase in its acceleration. Do you see the language of that? calculate the increase in its acceleration. Imagine you had an acceleration of 5, and then your new acceleration was an acceleration of 10. What's the increase? Huh? Do you know what way they did it? They did it as a magnitude. So now that I'm thinking a bit deeper about this, how many people subtracted the two of them from each other? Yeah, go on, give yourself an extra 3. Sorry, my fault. I didn't think of it like that. They have it down as the magnitude, but there's nothing to say that that has to be the magnitude, is there? No. So some of you might say A is 5. Sorry, the magnitude is 5. The way the book wanted it, the way Examcraft wanted it done was they wanted the magnitude to be 2, as in it's twice the acceleration that it used to be. So I think there's a bit of a mistake there. So if you did take them away successfully, you can probably give yourself another 3 on that. My fault. I didn't quite get that till now. Alright, so here's what happens, alright? Your t equals 6. We're going to reduce it by 12.5%, and most of you's got a t value of 21/4. I think it's 5.25. Okay. Next thing after that is we're going to go back to our previous equation, which is the 15t plus a half at squared, which is 0.5 t squared. That's for SP. Okay, and then 25t. Now, train Q has a different acceleration, doesn't it? So train Q, which is the second part, has a different acceleration. So a different acceleration would be a half at squared, and that still has to equal 285. Now anywhere I see t, I can now put in 21/4. Alright, saves a bit of time. You use the calculator, you multiply it all out, and what you'll end up getting on this side is you'll get 441a/32, and you'll get that equal to 1959/32, and you'll get your a value equals 653/147 ms squared. Alright, so we're going to give full marks for 2 different answers. Here's the 2 different answers. It's your old answer. What's the old answer again? It was a 1.5, wasn't it? The old answer was 1.5. So if you did 653/147, take away 1.5, what's that equal? Did you do that? Did you? What did you get for that? If you can. 865/294. Yeah, if you did 865 over 294. If you got that, my bad. You can give yourself full marks for that. The answer they had was weird. It was like this. They got the old acceleration. Sorry, they got the new acceleration and divided it by the old acceleration. And they got a k value, or a magnitude change, of 1306/441. To be honest, the language of the question doesn't specify magnitudes, so in my opinion both answers should be fully acceptable. Is that right? Cool.